This is chapter 6, air pressure and winds. So I thought I would start it with one of my favorite movies, which is Forrest Gump. I hope that you've seen it. And if you might remember that it starts off with the credits and a feather just floating in the wind over, I guess, Birmingham, Alabama. And the feather is supposed to be a metaphor for the transitory nature of life and the fact that we can't predict what's going to happen to us. But I'm here to tell you that you can predict what forces are on that feather. And you can apply physics to Forrest Gump and this feather, and that's what we're going to do now. So let's get started with what you know. And you have been doing a lot of work on convection and its relationship to the stability of air. We've been looking at soundings and the vertical profiles of air, and convection is all about the vertical movement of air. And now we're going to pair that with wind, and wind is the horizontal movement of air. Together, the horizontal and vertical movement of air produce circulation, which keeps the poles from being perpetually frozen and the equator from being perpetually hot, and mixes the atmosphere so that we have a more temperate environment. So let's get started on that. You already know about expansional cooling and compressional warming. Very quick review. When warm air rises, it expands and cools, expansional cooling. That cool air then starts to be more dense and sink and contract and warm. That's compressional warming. Looking at this cycle of compressional warming and expansional cooling, it can be combined with horizontal movement of air. So we're going to talk about with these model skyscrapers. I think they're a bit better than the model helicopters that were at the last chapter. And we start off with two model skyscrapers that have the same temperature and that have the same pressure and the same number of molecules. So let me show them to you. Get my mouse over here. They're right here. And they're identical. But we decide to warm one skyscraper and cool the other skyscraper. And when we warm the one skyscraper, well, you know what's going to happen there. That warm air is going to expand. And when it expands, it will send up a column that is quite high. And when we cool the other skyscraper, well, it starts to really contract instead. So this shrinks quite a bit. And in doing so, we go up to the 10th floor of the skyscraper. We go up into the atmosphere in the skyscraper. And when we go up there in the warm skyscraper, we realize that above the 10th floor, there's quite a bit of our parcel of air above us. There's quite a bit of that. There's higher pressure of air above us than if we were in the 10th floor of the little squat cold skyscraper, and there would be very little pressure above us on the 10th floor. So we can say that there is a high atmospheric pressure area on the 10th floor in the warm building, and there is a low pressure in the atmosphere in the cold building when we're in there. All right, I hope you'll go with that. High pressure above us in this warm building and low pressure above us in this warm building, because air pressure is always measured above you. So if we do that, we could say that there's, like I said, a lot of pressure above us on the 10th floor. Just move this around. Now the second law of equilibrium comes back into play. Everything wants to be in equilibrium, and if you have high pressure on the 10th floor in the warm building and low pressure on the 10th floor in the cold building, that's not an equilibrium. So what happens is that the high pressure from the warm building will just start flowing over to the low pressure in the cold building in an attempt to balance things out. Well, now you've got a lot more air mass coming into this cold building. And when there's a lot more air mass in here, this is all going to start to get more dense and sink. Soon you're going to have high pressure at the surface of the cold building. That makes sense, right? You'd have high pressure at the surface of that cold building. And now you can think of a mnemonic. You can think of a mnemonic that says sinking sky, warm and dry, surface high. Because we know that that air will warm and dry as it sinks down by compressional warming. So the mnemonic is sinking sky, warm and dry, surface high. Let's keep going on that and this circulation. Well, when we get to that point where there's a surface high here, well, then you have to think, where did that surface high come from? That came from donating all the air mass from our warm building. Now our warm building has a lot more air mass. Now there's a surface low at the bottom of the warm building. Well, that's not going to do. It's an equilibrium problem. And so the high surface pressure from the cold building is going to start flowing over to the low surface pressure in the warm building. And so now we have a new mnemonic that eventually, when things are rising slowly, because remember, gravity's still pulling down on whatever is rising. Rising slow makes clouds to blow, lots of condensation, but results in a surface low. Because you know that this high atmospheric pressure is going to move to areas of low atmospheric pressure. And when it moves out, it's going to leave less pressure in the column behind. There's going to be low surface pressure. So here's a mnemonic for you. Over time, a rising slow, clouds to blow, surface low. Believe me, that'll help you out a lot in your weather analysis. See you soon.